We're now in week 2. This is probably going to be the hardest week for most of you that don't have a finance background, because we're going to talk about the time value of money. You should have already seen in the PowerPoint the specifics of it, but I know even with the PowerPoint, a lot of you will still struggle. So what I've done is I've actually created practice problems for you in the discussion board. If you go to the bottom of the discussion board, you will see practice problems. We're going to work through one of those right now. So what I tell most students to do with this is to set it up like 5th grade math, where they made you show your work. We're going to show our work just so that you can kind of follow, because the good thing and the bad thing about a calculator, Excel or a calculator, it's going to give you an answer regardless of what information you put in. The bad thing is you could be totally off and have no idea because you still got an answer at the end of the day. So there's 5 different variables that you guys learned about. The first one's present value, then future value. This is payment, PMT. Interest is interest per year on the calculator, or NPER, depending on if you're using Excel or the calculator. This is the number of payments. The reason that time value of money is so important, and pretty much all of you are going to have to deal with it at some level, is because that's how they calculate the interest on what you earn and on the interest on what you pay. So let's say you have a mortgage and you get a 30-year mortgage and it's a $200,000 mortgage. You find out you can make $1,200 a month payments because you got a 6% loan. It doesn't sound that bad because that's pretty close to what you were paying for rent, and now you have an asset. But if you actually do the math, take that $1,200 times 360 payments, you'll find out you're spending more than $400,000 on your $200,000 house. So even though you're getting a good rate, the time value of money, the longer it stays in, the more money it costs you. Well, the same principle is true for retirement. The earlier you can start and put that money in, the more it can compound on itself. It's called compounding interest, where you're actually earning money on your interest. This is why a lot of people say the rich keep getting richer, because they make money off of their interest. So the way this works, we're going to do an example. I'm actually doing example number 1 on the discussion board, so you can follow along from your discussion board if you want to. The question says, let's say I want to be a millionaire by the time I'm 52. I just graduated college at 22. How much do I need to invest today to have $1 million in 30 years if I were able to earn 10% a year? Well, I already put the math in here. You'd find out the number of years by taking 52 minus 22, which I've already done. I've told you it's 30 years. So you know right here, N is 30. The easiest way to do this is when you find the easy information. N is always going to say months or years. And you want to make sure that you put in your notes whether it's years or months, because you're going to have to change this variable if it's monthly or annually. So it's 30 years. The other thing that's easy to find is the interest rate, because it's always going to have a percentage behind it. So in this case, we said that we're going to get 10% a year. So this becomes, our interest is 10% a year. The other thing it tells you is that you want to have $1 million by the time you retire. $1 million, am I getting it today or sometime in the future? It's not today. I'm looking for sometime in the future. So I know it's got to be future value. So future value here is going to be $1 million. Okay? So in this situation, I only have 2 left. Like we talked about in the notes, you only need to have 3 to solve. You don't have to have 4 out of the 5 variables. So you only have to have 3. So we have 3 already. We have 1, 2, 3. We don't have any more information than it's giving us, so we know we can solve now. The way you solve is to hit compute for the calculator, and I'll show you in another video the calculator by itself, and you also have videos for Excel if you want to solve through Excel. But you're going to hit compute PV. We know we're solving for present value because it says how much money do I need today. Present value is a one-time amount, and it's today. It's not any time in the future. Payment is ongoing. It's like your car payment. You don't pay for it once, you keep paying for it every month. A payment is going to say monthly. It's going to be annuity or an annual payment. A present value is a one-time fee. So in this situation, this is what we're going to put into the calculator or Excel, depending on which one you want to use. You're going to put $1 million, FV, 10, I/Y, and 30N. For those of you using the calculator, the biggest mistake I see most people do is they don't clear the calculator. You clear the calculator by hitting second FV. And so it's not just a little clear button in the bottom left, it's actually second FV. That clears out your calculator. The other thing that they don't do is they don't change the interest. And you have to do this whether you're using the calculator or Excel. To change this interest rate, right now, this is why this part is so important. This says 30 years. So if I'm putting 30 as the number of payments, my interest rate has to match. So the interest rate is 10, but it's 10 This is 1 time per year when this says 1/y. The way that you change that on the calculator is second I/y. This becomes P/y when you do that. You want the P/y to be 1 in this situation. P/y is payments per year. So you want the payments to be set at 1 payment per year if you're putting in 30 down here. Now if this were a monthly thing and I wanted to find out what my payment were going to be and per month, I would change this to 360 because 12 times 30, and I need this PY to calculate the interest at 12, not 1. So make sure that this is set correctly to either 1 or 12 depending on what the question asks. When you put all of this in, you should get for your present value $57,308. Okay? So that is what we have for this. There's examples underneath the PowerPoint presentation for both Excel and the handheld calculator.